What's up, guys? Hope you did well on your test yesterday. If you're watching this after test day, which you should be, we're starting a new chapter today, and this chapter is on functions. And in math, we have a lot of weird words for some of the stuff we do, and functions is kind of like a weird word, but it's going to be very similar to what we've done. You guys are going to notice a lot of similar themes to what we've done in the last two chapters here. So what we have here is that functions are, let me see if I can better. A function is a relation that assigns exactly one output value for one input value. So basically, imagine a machine, and you put something in the machine, and then something pops out of the machine. Okay, kind of like a box right here, right? And you put something into it, and then something pops out of it. Could be anything, right? So you put in, let's use like we put in the letter X into the input machine, and then out pops a Y. So something inside that machine changes whatever that is, right? It changes it. And that's what a function does, is it changes it. Okay, and it changes it in a particular way. A function rule is what happens inside this machine. For example, say it's not a letter, but say we put a number in. Say we put the number 1 in and out pops a 3. Well, then the rule in the machine might just be that it takes whatever you put in it and it adds 2 to it. Maybe that's the rule. Maybe that's the function rule. So the machine is you put a 1 in and out pops a 3. Or you put a 5 in and out pops a 7, because the rule is to add 2 to it, right? And that's what a function essentially is, okay? And what we're going to do today is we're going to talk about a couple different things with functions. First is the rule that's inside the function is really an equation, right? And you guys know what equations are. Something equals something, right? The next thing we're going to talk about is tables. And the table looks, and I can do it real quickly, like this, which basically says we have the rule in here, say is +2, and then I give you a bunch of inputs, 1, 2, or 3. And say if I put a 1 in the machine, what do I get out? Well, you add 2 to that, you get a 3. And if the rule is the same all the way down, then it's, what if I put a 2 in? Well, you get a 4. What if I put a 3 in? Oh, you get a 5, right? And so essentially this is what a table looks like. And then ultimately our goal with functions is to take this information and then put it on a graph. So we can, like this, right? Like a coordinate grid, right? And we put it on a graph. And that's going to be our goal for functions, okay? So let's go ahead and hop into this. The first example we have here says that the output is 7 more than the input, okay? So the function rule is x plus 7. And we refer to all inputs as x and all the outputs as y, which is kind of cool because that's how it works on a graph, right? We have the x and the y-axis. So all the inputs are x and all the outputs are y. So if the function rule is x plus 7, then all we have to do is, just like what we did with expressions, is substitute in, right? If the function rule is x plus 7 and I tell you that x is 10, then all you do is put in a 10 where the x is, and then really it's 10 plus 7. And what is 10 plus 7? 17. So if the rule is x plus 7 and your input is 10, then your output is 17. And then we would go down through here and do this for all of these, right? If I tell you that the input is 12, then put 12 in here. And the output is 19. Or if the input is 14 plus 7, and the output is 21. And that's how you fill in a function table. That's it. It's just like solving an expression, but doing it a bunch of times with a bunch of different numbers. That's really all there is to it. Here's another example. If I tell you your inputs here, and I tell you that the rule is 3x, hopefully you guys know that anytime you have a number and a letter right next to each other, that means multiplication, right? So this is 3 times x. Then you tell me what the outputs would be. So if I tell you that the input is 0, so you just put in a 0 there for x, and 3 times 0 is 0. What would the output be if the input is 2? You don't have to stop the video or anything here. Just kind of think in your head or say it out loud. What do you think the output would be if my input is 2? Well, 3 times 2 is 6. What would the output be if my input is 5. My output would be 3 times x, right? 3, and x is 5. The output would be 15. Basically how it works. You could have a rule that is a little bit more complex, right? It could be a 2-step rule. But again, if we're following our order of operations, just like we would with any expression, it works just like this. You just plug in your x value for your variable. And you'll notice that I just put the x in for the x in each one of these, and then you can find the output, right? As long as you follow this rule right here, you'll put your input in and you'll get a new output. 3 times 0 plus 5 is 5. 3 times 3 is 9 plus 5 is 14. And 9 times 3 is 27 plus 5 is 32. And that's how functions work. Okay. Now what we could do with that information once we create these tables is, if you'll notice, that what we have is x and y values. So we can actually create coordinate points, right? We create ordered pairs. Like we could say this point is 0 for x value, because that's how ordered pairs go, right? Remember, ordered pairs are like x, y. And if this is x and y, then we can make this ordered pair 0, 5. And we can make the next ordered pair 3, 14. We can make the next ordered pair 9, 32. And we can create a graph out of this. It might look something like this. If you were to do problems with functions, you might get a problem like this. Jasper hikes 4 miles per hour. The function rule that represents the situation is 4x, right? 4 times the number of hours he walks will tell us how many total miles he goes. Make a table to find how many hours he hiked when he has gone 8, 12, and 20 miles. Okay, so what we'll do here is, since these are the outputs, right? We just don't know. We know what the miles are. We don't know what the hours are. So let's go ahead and fill in this information. 8, 12, and 20. Now this one is kind of cool because it works backwards, right? It actually gives us the output, but we have to figure out the input, right? So if something right here times 4 gives us 8, then we're trying to figure out how many hours that would be. So we could work backwards, right? So what times 4 would give us 8? That's 2, right? 4 times 2 would give us 8. What times 4 would give us 12? Well, 4 times 3 would give us 12. And what times 4 would give us 20? 4 times 5 would give us 20, which means that our inputs are 2, 3, and 5. 2, 3, and 5. Now with that information, we can actually create a graph here to show what it looks like for him to go hiking, right? If we create our ordered pair here of 2, 8, right? 2 hours, 8 miles. 3, 12, or 5, 20. We can actually take these points and graph them on our graph over here to show what that looks like. So, for example, 2 hours going 8 miles would be 2 hours, and then 8 is right about there. The next one would be 3 and 12, so we go 3 hours, and that's 12, which would be right there. And then 5 and 20, which would be 5 and 20 is right here. So it looks like that will be the graph for Jasper and his hiking. Now there is one other type of thing that I would like you guys to practice today, and that is to be able to look at a table and then tell me what the equation would be. So for example, if I gave you the table with all the inputs and outputs, can you tell me the rule of what's happening, right? So for example, if I were to give you guys, let's go back to this page right here. It would almost be like if I covered up the middle part here and said, okay, well, the output 0, or the input 0, the output's 5, the input's 3, and the output's 14, the input's 9, and the output's 32. Could you tell me that that was the rule, 3x plus 5? Well, I'm not going to make it that complicated. Yeah, we'll start here. If the input is 1 and the output is 16, your first thought could be, oh, well, the rule is plus 15, right? Because 1 plus 15 gives you 16. So we could just say that the rule is the output equals the input plus 15, right? So x plus 15 is the rule that gives us the output, y. But if we look on and we see the next one, 2 to 32, then we think to ourselves, okay, well then the rule must also apply there. 2 plus 15 doesn't give me 32. So although that was a good thought for the first one, it works for the first one, it doesn't work for all of them. So it's not a rule. That's not going to be it. So then we have to start thinking to ourselves, well then, what can I do to the input that gives me the output here that works for every single one of these? 2 to 32, 3 to 48, 4 to 64, and 5 to 80. Well, after some trial and error, you might find out that what you're doing here is you're actually multiplying this first number times 16. 1 times 16 gives you 16. 2 times 16 gives you 32. 3 times 16 will give you 48. So the rule must be you're multiplying the top number here, the input, multiplying the x by 16. Now, how do we show multiply x by 16? Just 16x. And the way we write an equation for functions is we started off with the output is equal to whatever we're doing, whatever the rule is. The rule is 16 times the input. So y equals 16x. And that's going to be your answer to this type of problem right here when I give you this and ask for the equation. Let's try this one. See if you can figure out what this rule is. Go ahead and write it down or just kind of say it out loud and see if you're correct. So I look and see what's happening between the first two inputs and outputs. We got 0, 0. So I can't really tell anything about that, right? I know it's not addition or subtraction because those would change. So then I go over to the next one and I see 1 to 4. Well, what's one way to get to 1 to 4? Well, you could add 3, but that rule doesn't work for 0, 0, right? Because 0 plus 3 would be 3. So it's not plus 3. Could be 1 times 4. That could be it. Let's go ahead and check the next one and see. 2 to 8. Well, 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. So the rule must be to multiply by 4 because it works for all of these. So we would show this as 4x, right? 4 times whatever this number is gives us this down here. And we write that as y equals 4x. The output is equal to 4x. If you have questions, let me know. Good luck on today's assignment. See you guys tomorrow.